Quiz question. And it's a model car racing game, so there's model again. Same thing as before. What's the best? Wait till we're done with this. Time's wasted. We got it. Okay, it looks like we don't have quite the motivation to, some people are tired of clicking, so we're going to stop there. Okay, so B, layer, which is indeed my perspective, and I will try to justify that in a second, but let me take this question about models.
Okay, then, for example, when a user sends information into a form, and inside the back end, it manipulates the data in the form using a model.
Okay, so the question is, if the user enters information into a form, like on the web or something,
Yeah.
and then that information is sent to sent to some database where it's stored or manipulated or edited or whatever happens, is that considered a model?
Yeah.
Well, I would say that the model is not, the model is the set of all information that you store about some things in the real world. And I might even want to qualify the things in the real world when we're talking about video games or something, right? Because you might say, well, we have this thing called, you know, some sort of monster or whatever. We modeled a monster, but it's not a thing in the real world. But anyway, but you know what I mean. Something that's outside the computer system, even if it's just in someone's head. The model is the set of all of those, all that information that's stored, plus also rules about it, like, you know, if this field has this value, then this field can't have that value, or, you know, whatever. And then, as I mentioned before, the model includes things like, maybe there are rules about if there are physics models, right? If this thing bounces off this thing, it has certain elasticity, or it has certain momentum, and things happen like that. So models can involve rules that are interactions, as well as constraints, things like that. So, I mean, we might, for instance, store the latitude and longitude of a place. So we could say we're modeling a location on the Earth by latitude and longitude, but you would have some constraints, like these numbers can't be negative, and they can't be greater than 360. Or you might do something different, but that would be one possibility, right? Because there's no latitude less than 0. There's no latitude greater than, well, latitude goes from 0 to 180 and then south. So anyway, whatever the rules are on latitude and longitude, that would be part of the model. It's constraints, restrictions, rules. So you're asking about one particular piece of data. I would say that could be one little part of the model.
Okay. Thank you.
That's how I would use the term. Okay, good. So let's look about this as layer. Okay. So a layered model usually means, or it means, we usually write it in layers, but it's not a layered model just because you write one thing above another, right? So these layers have to have meaning. And here, I have identified 4 layers, and the point of a layer is the things in the upper layer. What they do is they do their job by interfacing with the layer one below. Now, there's lots of people will break this rule, and maybe the top layer communicates directly with the bottom layer. But the pure layer model is the user interface does things by talking to the game logic. So the user interface might say, you know, can I turn left at this point? And the game logic might say, yes, you can, or no, you can't. So that might affect how the user interface works, if you've got a little steering wheel. The game logic, in this case, talks to drivers. Driver here not meaning someone's holding the steering wheel or pressing the accelerator, but driver in the software driver. And you've probably all installed drivers on software or seen a little box saying you have to install a new driver. And a driver is the term for kind of the interface between an actual piece of physical hardware, like a printer driver, okay, accelerate, and then the driver will tell the model car whatever that means. Run the wheels faster, or rev the engine, or shift gear, or whatever. Okay, because these are presumably going to have little computer chips in them themselves. So we can divide parts of the system, modules of the system, and sort of functionality into these 4 layers. And then each layer sends commands to or talks to the layer below and gets information from, potentially, the one above. But the idea is, for instance, the model car here knows nothing about the user interface. And the user interface knows nothing about the model car. The user interface might look like a model car. It might have a little accelerator or button or something like that. But the actual coding in there, the user interface is worried about, this is on a mobile phone, so where did you press, what pixels, how maybe you can tilt the phone in a certain way, and that makes a difference. That's what the user interface is worrying about. And then the game logic is worrying about things like, oh, you're pressing the accelerator and the brake at the same time. What does that do? Or something like that. Okay? So, it seemed to me that, when I wrote this trying to make it those 4 layers as explicit, fairly explicit, not going to say as explicit as possible, but almost as explicit as possible, in the description of the game and some of its implementation aspects. Any questions about that one? Okay. So this whole architecture notion is definitely slippery. It's almost like, I gave the example of I showed you some architectural styles for buildings. Well, what if you had never seen a building before? Then it would be much harder to understand what Victorian means. You've all probably, I imagine, seen Victorian buildings. Many of you have been to San Francisco or someplace that has a lot of Victorian buildings. But if you hadn't seen them before, you might not it would be trickier. And so, or probably maybe you've had that experience in music where you say, oh, this music is in this genre, and your friend who knows more about music says, it isn't really that genre, it's another genre because of something. You say, oh, I like jazz. Oh, no, that's not jazz, that's progressive jazz, because it's different. And so, the more you know about something, the more attuned you become to these categories and these commonalities that architecture, I'm using the term architecture to sort of capture that notion. So this is definitely a hard aspect of this course. Always hard, every quarter. Don't feel bad about it. But it is, I think it's important because it gives you, hopefully, at least an awareness, if not intuition. Not something you can do yourself, but awareness that software design at the very largest scale is something that people think about. It isn't just a random haphazard collection of things. There really are structures. And hopefully, starting a little bit this quarter, and then if you go into software engineering or something related to software engineering, hopefully over the next 5, 10, 15, 20 years, these concepts will become more and more useful and meaningful.